Octopuses aren't just strange, they're unsettling. These creatures can unscrew jars, solve puzzles, open locks, and escape sealed tanks, not because they're panicking, but because they're curious. They've been filmed walking on two arms like land animals, collecting shells and rocks like tools, and even stealing cameras from unsuspecting divers. They don't just hide, they perform. An octopus can flatten itself to look like a flounder, spread its arms like a lionfish, or slither through the water like a sea snake, all to confuse predators. But a few days ago, I saw a clip that took this intelligence to a whole new level. An octopus dragging coconut shells across the ocean floor. At first, it looks ridiculous, almost funny, but nothing about this behavior is random. That octopus is preparing for a future threat that hasn't even happened yet. When danger arrives, it climbs inside the shells and pulls them closed, turning them into a portable bunker, a shelter it built in advance. To scientists, this single act is extraordinary because it shows foresight, the ability to imagine the future and plan for it. That's something we once believed only humans, apes, and a few birds could do. Some researchers still argue over whether this counts as true tool use, but here's what can't be debated. This animal is choosing discomfort now for safety later. That's planning, that's delayed reward, that's intelligence. And this is where the mystery deepens, because the octopus isn't a mammal, it isn't a bird, it's a mollusk, a distant cousin of clams and snails. Soft-bodied, solitary, short-lived, and yet capable of complex, flexible intelligence. This tiny act, carrying pieces of the ocean to build a future shelter, forces us to rethink everything we thought we knew about evolution and intelligence itself. And that's just the beginning of how strange octopuses really are. They've been filmed playing with pill bottles like toys, shooting jets of water at lights just to turn them off, seemingly for fun. Unscrewing jars from the inside, escaping tanks at night, hunting in neighboring aquariums, then calmly returning before morning. One octopus in New Zealand became so notorious for breaking out to eat sharks that the aquarium installed motion sensors just to stop it. But here's the part that should truly blow your mind. Intelligence evolved twice on Earth, once on our branch of the Tree of Life, and once entirely independently in cephalopods. And the octopus is the clearest proof of that split. Because we often say intelligence requires society. Dolphins, elephants, crows, primates, all social animals. But octopuses? They're loners. They avoid each other. They don't raise their young. They meet only to mate, and then they die. So how did a creature with no social structure, no cooperation, and arms that literally think for themselves become one of the smartest invertebrates in the planet? To understand that, we need to look inside the octopus, specifically its nervous system. Humans have centralized brains, one command center, one authority. The octopus does not. An octopus has hundreds of millions of neurons, comparable to a dog, but nearly 2/3 of them aren't in the brain. They're in the arms. Each arm contains its own clusters of neurons, local processing centers capable of making decisions on their own. This isn't delegation, this is autonomy. Even a severed arm, and yes, they regenerate, will still explore, react, and recoil from unpleasant textures. The arm doesn't wait for permission, it decides. And suddenly, their hunting strategy makes sense. Octopuses reach into dark crevices, under rocks, into spaces their eyes can't see. If every sensation had to travel back to a central brain, it would be too slow. So instead, the arms think locally, while the brain handles strategy, memory, and navigation. But touch isn't all they sense. Each arm is covered in suckers, and every sucker can taste. Octopuses don't just feel their environment, they sample it chemically. Every surface becomes information. And then there's their vision. Octopuses have camera-type eyes, lenses, irises, retinas, almost identical to ours, a stunning case of convergent evolution. But here's the twist. Human eyes have a flaw, a blind spot. Octopus eyes don't. Their photoreceptors face the light directly, with wiring tucked safely behind. No blind spot, perfect visual continuity. They can also see polarized light, something completely invisible to us. This allows them to detect transparent prey and possibly communicate using skin patterns predators can't see. And yet, despite all this, octopuses are likely colorblind. So how can an animal that changes color flawlessly not see color? Because the skin itself may be able to sense light. Their skin contains opsins, the same light-sensitive proteins found in eyes. This suggests octopuses may perceive color directly through their bodies without routing the information through the brain at all. They don't look at their surroundings and decide what color to be. Their skin responds automatically. This is a completely different model of perception. We see, then think. Whales hear, then map. Octopuses taste, touch, and possibly see through their skin. And that brings us to their camouflage. Unlike chameleons, which slowly change color for signaling and temperature control, octopuses use muscular control. Thousands of pigment sacs expand and contract in milliseconds. Reflective layers add blues and greens. Deeper layers scatter light for whites. And beneath it all, muscles reshape the skin, forming spikes, ridges, and textures. They don't just copy color, they copy structure. So the question becomes unavoidable. Is the octopus consciously deciding how to camouflage, or is this an automatic response? The answer appears to be both. They can learn patterns, but the execution happens faster than conscious thought. This isn't human-style intelligence, it's something else. Octopuses solve puzzles, recognize individual humans, learn by watching others, and even play, behavior that serves no survival purpose. They plan multi-stage escapes, they remember routes, they prepare in advance, and yet they live alone. So how did this intelligence evolve? Not through social complexity, but environmental complexity. They hunt many types of prey, live in chaotic habitats, face constant threats. For a soft-bodied animal, survival requires intelligence. And when problems become complex enough, intelligence emerges, even without society. The octopus exposes the flaw in how we define intelligence. We judge minds by how similar they are to ours. But the octopus shows us something radical. There isn't one kind of intelligence, there are many. And if such alien minds can exist on Earth, what might exist elsewhere in the universe? Perhaps intelligence doesn't always speak. Perhaps it doesn't build cities. Perhaps it thinks in ways we don't yet recognize. The octopus didn't break the rules of evolution. It revealed that the rules were never as simple as we thought. But maybe the most unsettling truth about octopuses isn't how intelligent they are. It's how completely that intelligence defies our expectations. For centuries, we've assumed intelligence follows a familiar path. Bigger brains, social groups, communication, technology. We imagine minds that think like us because that's the only reference point we have. The octopus shatters that assumption. Here is a creature with no language, no culture, no long childhood, no shared knowledge passed down through generations. And yet, it plans, it remembers, it improvises. It solves problems it has never encountered before. Its intelligence isn't centralized, it's distributed. Thought doesn't sit neatly in a single command center. It flows through arms, skin, sensation, and movement, blurring the line between mind and body. For an octopus, thinking isn't something that happens before action. Thinking is action. And that challenges one of our deepest beliefs, that intelligence must be conscious in the way we experience it. When an octopus changes color to match coral, is it deciding, or is its body responding faster than thought itself? When an arm reaches into a dark crevice, tasting and exploring independently, where does the decision actually occur? The uncomfortable answer may be that intelligence doesn't always require awareness, at least not awareness as we understand it. This raises a profound possibility. What if consciousness itself comes in forms so different that we fail to recognize them? There's a concept in biology called Umwelt, the idea that every organism experiences its own private version of reality, shaped by its senses. A bat lives in echoes. A bee sees ultraviolet patterns. A shark navigates electric fields. An octopus may live in a world of texture, chemistry, pressure, and polarized light. a reality stitched together by 8 semi-autonomous limbs and a nervous system unlike anything else on Earth. Trying to imagine that world using human intuition may be impossible. And that matters far beyond marine biology, because for decades our search for extraterrestrial intelligence has been shaped by a single assumption: that intelligent minds will announce themselves in ways we recognize: signals, mathematics, technology. But the octopus offers a warning. If intelligence can evolve twice on Earth, independently, into forms so radically different, then the universe may be filled with minds we simply don't know how to look for. Minds that don't broadcast, don't build, don't speak. Minds that think through bodies rather than symbols. The octopus doesn't just expand our definition of intelligence, it exposes how narrow that definition has always been. Intelligence isn't a ladder with humans at the top. It's a landscape shaped by environment, necessity, and survival. Human intelligence is optimized for cooperation, storytelling, and abstract thought. Octopus intelligence is optimized for adaptation, perception, and real-time problem-solving in a dangerous world. Neither is superior. They are answers to different questions posed by evolution. And that realization forces a humbling conclusion. We are not the measure of all minds. Somewhere beneath the waves, a short-lived solitary mollusk quietly demonstrates that thinking can take forms far stranger and far more alien than we ever imagined. The octopus didn't break the rules of evolution. It revealed that the rules were never written for us alone.